The next special consideration we want to attend to is, we'll refer to this as patterns of payments. And the time value, the basic issue here is that sometimes we have non-continuous types of patterns of payments, or non-identical patterns, so it doesn't conform to the annuity situation, but we'll have just different amounts that are received on different dates. So assume we have a contract involving payments of different amounts each year for a 3-year period. To determine the present value, we're just going to find the present value of each payment, discounted to the present, of course, and then we're going to add those up. So if we have an 8% rate, let's imagine that we have 3 payments each year. The first year we get 1,000. The second year we get 2,000. So we're looking here at right here. First year we get 1,000. The second year we get 2,000. The third year we get 3,000. We're just going to take each of those and discount them appropriately to find the present value of each one individually. So the first year, $1,000 discounted at 8% for 1 year is worth $926. $2,000 discounted at 8% for 2 years, so we have a different factor that we're using here, is worth $1,714. 3 years discounted at 8%, or $3,000 discounted at 8% for 3 years is worth $2,382. We then just add up all the present values, and that's the present value of the entire contract amount. We could use certainly patterns can be more complex than this. A common pattern might exist where we've got multiple different payments along the way, but then we also have an annuity. Let's assume a contract involving payments of different amounts each year for 3 periods. The annuity of $1,000 is paid at the end of each year from the 4th through the 8th year. So we're going to assume a pattern of payments in which the first 3 payments is identical to what we saw just a moment ago, but in years 4 through 8 we have a different pattern. We have an annuity. Now the annuity doesn't start at time 1, so we can't just take the value of the annuity and use that to directly. We've got to value the annuity using the table or using the formulas. We have to value that first at time 3, because the first payment starts at time 4. We're going to value this annuity back here at time 3, add that value to the $5,022 that we know the first payments are worth. So this is what our annuity looks like, in terms of a time scale, a timeline. We're going to take this entire annuity, value it at the beginning of the first period. The first payment has to come at the end of the first period, so that payment's at the end of the period. The first period that's relevant here for us is at time 4, so we're going to value this back to the beginning of the 4th period, which is also the same as the end of the 3rd period. When we do that, the value of a 5-year annuity of $1,000 using present value interest factor for an annuity is going to be $3,993. So the present, let's put over here, present value interest factor for an annuity was 3.993, and that assumed N equals 5, I equals 8%. We've got to go to Appendix D or Table 9.4 in the chapter. So now that we've found the value at time 3, that's not the value we need. We need the value back here at time 0, but we know how to do that. We're going to simply take the present value of this annuity for back over 3 more periods. So we're going to find the present value, let's say at time 0, is equal to the future value at time 3. All right, so now this the first step we found the present value. This is now the future value for purposes of the second step. We're going to divide that by 1 plus I to the n, where I is now still 8%, but n is now 3 periods. So discount the 3,993 back to the present, which falls at the beginning of the fourth period, right? In effect, equivalent to the end of the third period, and then we discount that by 3 more periods at 8%. So discounting it for 3 more periods, we now have to use Table 9.2 or Appendix B to find the present value of a single amount. That single amount is now this 3,993, and so we get an actual present value of $3,170, which we can basically see in this form. This is a hard concept for many students to grasp, so let's just go over it one more time. We need to draw a timeline. We identify when the annuity starts. We're going to value the annuity at the beginning of the annuity period. If the annuity starts at time 4, we're going to find the value at time 3 using the annuity formula or table 9.4 Appendix D. They're all the same thing. After we find that, we now have a single amount. We're going to value that single amount back, discounting it back 3 more periods using Appendix B or Table 9.2, or we can just use the formula for finding the present value. In other words, we can just take 3,993, divide it by 1.08 to the third, and that will equal 3,170. So we've taken a fairly complicated now set of payments that have a present value. We found the present value of the first 3. We did that earlier. Found it to be 5,032 in that form. Then we had an annuity that started at time 4. We found the value of that, the present value of that annuity. The final step is we take that amount that represents the first 3 payments, the value of the first 3 payments, this amount that's the value of payments at time 4 through 5/8, we simply add those two together, and we're going to get 8,192, which is the value, the present value at 8% of this entire, I'll circle it in red, that entire payment stream.